were approached by CTF.ae to show us something really, really cool. They offered us their time. They got us Yousef here, Mr. DeadPackets, an actual hacker, not like us, and he's going to be explaining some really cool stuff. And if you stay till the end, there's some cool surprises and awards for everyone. So stay tuned. Yalla, Yousef, you can start now. 3 minutes are over. And oh, Ahmed, thank you, saving the day. We need to start recording.
Recording, yep.
Yes.
I started already, Adham.
Okay, thank you.
All right.
Saving the day. Okay, now you won't see me again for the rest of this session.
I'm finished. All right. Okay. So I just want to take this chance to. We're still warming up to 10:05, so I'm just going to take this minute to just explain for those of you who are here what we're going to be talking about, in case you want to run and text any of your friends and tell them not to miss out on this opportunity. So I'm going to save the introduction till 10:05. So for myself, so I'm just anonymous up to this point. I mean, Adam introduced me, but you know. What we're going to be talking about today is we're going to take 3 web challenges from easy, medium, hard, but like hard from a very beginner perspective. So we're just going to increase the complexity of the challenges tiny bit as we move on. We're actually going to allow you to follow along, but this is a surprise, so we'll keep that until we're in. And there's going to be Q&A at the end. And if you guys have a question, my philosophy is that you should ask the question immediately in the chat. And if I ignore, like I have the questions on one screen, I will see your question. But if I ignore your question, just know that your question was technically off topic, or like not necessarily, like I'm going to diverge too much if I answer your question. If your question is on topic, I'll answer it directly. All right, let's get started. We have hit 10:05, the golden mark. So good evening, everybody. My name is Yousef Awad. I'm head of engineering at CTF.ae. Some of you may know me as DeadPackets on the CTF.ae Discord server. Some of you may know me as Yousef Awad. I am an AUS alumni, graduated with a Bachelor of Computer Science in Engineering. And some of you might know me as the annoying person that you see at CTFs who just like bothers you and gets on stage and makes jokes all the time, because I find myself to be a very funny person. So I am all 3 of those people, and today I'm very excited to present to you with a nice workshop about an introduction to CTF, and an introduction to hacking websites and web security vulnerabilities. So first, let's start with a quick introduction to CTF.ae. So CTF.ae we are a CTF company based here in the UAE, and we build CTF ecosystems and cyber range labs. So those CTF competitions, we build them, and we build cyber range labs, which is similar to a CTF, but is more, how can I say, immersive and realistic. We are the organizers of many prestigious CTF events that you might have heard of. We Hack in the Box Amsterdam, Pro CTF, where a bunch of pro teams from around the world came to participate in Amsterdam. Dubai Police CTF, which was actually, I think, a week or 2 ago. And ADQ CTF, also a few months ago. And GITEX Africa CTF, which was actually the first GITEX to ever take place in Africa. So let's talk about CTFs. What is a CTF? You've heard me say the keyword like 20 times now. So a CTF stands for Capture the Flag, right? Some of you may know Capture the Flag from FPS video games, like Halo and such, where the goal is to capture the flag from the enemy team, right? In cybersecurity, Capture the Flag is somewhat similar, except it's a form of a cybersecurity contest where the goal is to collect a flag from a cybersecurity challenge. And the flag is usually a piece of text. And you're going to actually see what a flag actually looks like once we solve the first challenge. So when we talk about the CTF, we mean a cybersecurity competition. And these challenges are usually vulnerable applications. They might be incident response questions or even digital forensics artifacts. So it's not always, you're not always hacking into something. You could be protecting something and you'll get the flag if you successfully protect this thing, or the flag could be an answer to a question. Again, you'll see more examples of this as we move forward. And CTFs are the best way to get introduced to cybersecurity, especially ones that are aimed at beginners. So if you read in a CTF description, this is aimed for a beginner, you should absolutely join it if you want to get introduced to cybersecurity and you want to get that exposure. Even if you don't win, even if you don't solve anything, it is the best way to get hands-on experience with the cybersecurity industry. So with that being said, let's dive right into our content with an introduction to web hacking. So what is web hacking? Web hacking is one of the most expansive categories of offensive cybersecurity. I might be a little bit biased. I mean, my job as a penetration tester, most of my job is attacking web applications. And in CTFs, my famous category, or my favorite category was web applications. So might be a little bit biased. It involves anything that abuses web security vulnerabilities, and not just vulnerabilities, but also design flaws. And you'll see an example of this as we move forward with our workshop. Famous examples of web vulnerabilities are something called the OWASP Top 10. So if you Google what the OWASP Top 10 is, it is a list of the top 10 prominent vulnerabilities in web applications year after year after year. This list actually gets updated every few couple of years. So with that being said, why not just dive into our first challenge of the day? This challenge is called Keep It Simple, and it is a reference to what we are going to be doing. Give me a moment. All right, just making sure that I have the challenge in front of me on another screen. All right, so the first thing we need to learn before we take a look at the web challenge is the mindset to approaching a web challenge. All right, and this is very important. I want you guys to focus on this. We're going to be seeing this a lot today. Move the mouse out of the way. So first thing I want you to know is you always read the description. Okay, when I put this first, and you might be wondering, Yousef, why did you put reading the description first? Aren't you going to explain to me what a web challenge is? No, I want you to understand this point, because especially when it comes to CTFs, a lot of players miss the point by not reading the description. So number one, always read the description of the web challenge, or any challenge in general. Next is we want to identify the goal of the challenge. Am I supposed to hack some admin account? Am I supposed to hijack the website? Am I supposed to take down the website? You know, you never know what the objective is. We want to analyze the technologies that are being used by the website. All right, is this website using PHP? Is it dynamic? Is it a static web page? What's going on? And then with all these pieces of information, we are going to plan an exploit path. So I call this read, identify, analyze, and plan. Okay, read, identify, analyze, and plan. You're going to see this repeated throughout the 3 challenges that we are going to solve today. And it is my recipe for solving web challenges. And it can be applied to any other type of CTF challenge. So let's take a look at Keep It Simple. So what is Keep It Simple? I realize I have to share, keep switching what screen I'm sharing, which might be a bit annoying. Let's see. Here, this is Keep It Simple. Let me share. All right, give me a moment. This is getting quite complicated. I have to make a separate Chrome. All right, here we go. Where will I put this? Okay, let me put it in my main screen. Now all of a sudden you'll see me, my face is filled up. All right, so let's share. Let me know if you guys can see. I'm on an ultra wide screen, so that might be a little bit of a hindrance, but let me know if you guys can see. I'm just gonna zoom in. All good? All good. All right, so this is the challenge, Keep It Simple. Okay, let's take a look at our CTF platform over here. We can see that there is no description. Okay, description literally NA, and I just have a place where I can put the flag, and I have a challenge link. So let's just go to the challenge. All right, we see the challenge. Let's go back to, okay, I think I should just share my entire main screen. I feel like that would be so much easier if I'm going to keep going back and forth between the presentation. All right, let's hide this. All right, so read the description. We read the description. There is no description on this challenge. We identify the goal of the challenge, escalating to admin. How did I know that? Let's take a look at the challenge again. Keep it simple, nothing too complicated going on here. Should be easy. If you are an admin, click here. We click here. It gives us a nice error message. You are not an admin. Okay, so very clearly, the only thing I have going on here is I need to escalate to admin. There is no other weird thing that is going on. Okay. Some people will tell you, oh, view the source of the website. Let's view the source of the website. Sure, it's not a bad idea. Do you see any comments? Do you see anything going on? No, this is boot swatch and jQuery. These are normal things that happen in websites. There is literally nothing going on in this website other than the /admin. Okay, so /admin is we need to escalate to admin somehow. Great. Let's identify. Okay, we have a cookie called auth. I think I should have analyzed the website before. All right, let's talk about cookies for a second. Here's a fun question. I mean, we already answered it. How do websites remember who you are? They use something called cookies. Now, what are cookies? Cookies are small pieces of information that are stored in your browser by a website, and then that website can read that piece of information later. So most likely how this thing is knowing if we're an admin or not is through the cookies. And so you can use Chrome or you can use some extensions. I have an extension here. Okay, this is going to be tiny. I don't think you guys can see this. How can I make this bigger? Yeah.
I think you can use the magnifier app from Windows.
That is a good idea.
If you prefer.
Yeah. I'm just going to have to learn how this works, though.
You can, sorry, Yousef, you can just Windows key plus to zoom in without opening that. So Windows key plus and Windows key minus.
Okay, that zoomed in everything. Okay. All right, so you guys see this? In the cookie editor here, we have a cookie called auth. This is the name of the cookie. I expanded. The name of the cookie is called auth, and it has this weird value. Okay. So clearly, when we talk about web challenges, you need to work with what you're given. Okay. If you are given something, you need to work with it. Don't try. I mean, I saw one of the biggest problems is that somebody learns some kind of attack in web. They learn SQL injection. They're like, I'm going to SQL inject this website. Where is the SQL injection? Why? You guys need to learn Occam's razor, which is the simplest solution. I believe that's what Occam's razor is. Always go with the simplest solution first, right? So this auth cookie, all right, I'm going to copy this value, and I'm going to, how do I get out of this? Because all my 3 screens are right now. Okay. So someone asked what information is stored in cookies. Anything, literally up to the website. The website can store your username, what your language preferences are, what do you want ads to track you or not. All right, so this value, I'm going to open a notepad here, and I hope this notepad doesn't, okay, thank God it's a blank notepad. Let's take a look at this value here. Okay, does this value look like anything to us human beings? No, it doesn't. It looks like gibberish. Well, from my experience, I know that this is base 64. How do I know that it's base 64? There's some equals at the end here. There's alphabetical. The alphabet is, I think, A to Z with some numbers included, and some letters are capital and uppercase. So I know from experience this is base 64. So what happens when we take this cookie, and I'm going to go to my favorite base 64 decoder, which is CyberChef. Let's go to CyberChef. CyberChef is a website made for us by the nice people at GCHQ. That's the UK government. So we're going to put the base 64 in this input box. I'm going to grab this from base 64, drag it here, and it decoded. And this is the decoded version of this. So we can see that it's a JSON object that has a type key with the value set to user. Okay. So can anyone, just off the top of your head, what do you think we're going to do next from here? Let's just plan, right? We're going to plan. We're going to change to then encode. That makes common sense, right? I mean, I see something that says I'm a user, right? Nice, good. So let's do that. Let's change this to base 64 again. And I'm going to change this to admin. Grab this. Come back to keep it simple. We're going to open our cookie editor. Let me just zoom in, make sure you guys can see. I don't know how much this helps because it doesn't seem to be helping much. Well, hopefully it is. All right, and please don't move. Paste. I'm going to press save. We save the new value of the cookie. Take me back to my normal windows. Thank you. Let's refresh. Did anything happen when we refreshed? It didn't refresh. Nothing happened when we refreshed. Is the value still the same value? It is. Let's click here. And we get welcome admin. And we see this nice flag at the bottom here. And this is what a flag looks like. When we say capture the flag, this is exactly what we're asking you to capture. This piece of text down here. We can actually grab this and come to our platform over here, submit. Ta-da! And we have solved your first ever CTF challenge. And so let's go back to our presentation. Let's revise what we just did. Okay. We analyzed, there's a cookie called auth, and the cookie looks important. Let's focus on that. So we read the description. There was no description. We identified the goal, which is escalating to admin. We analyzed this cookie, and we realized that it could be decoded by base64, and it can be edited. And we focused on the cookie, and we exploited the cookie. So let's go over this again. We see that there's a cookie encoded in what seems to be base64. We know that it's base64 due to the alphabet. And decoding it reveals a JSON object that shows a user-controlled value. Now, guys, I want you to focus on user-controlled value or user-controlled input. It is going to be extremely important, all right? You're going to see it a lot. How could this be exploited? So, abusing user-controlled values or abusing user-controlled inputs. What is a user-controlled value or user-controlled input? It is if an input to an application can be edited, can be controlled by a user. I'm the user. It most likely can be exploited to cause unwanted behavior. Okay? This is why a common saying in application security or programming security is sanitizing user input. Anything that the user gives you, don't trust the user. Never trust the user. The user is not your best friend. He's not your uncle. All right? Always assume that the user is like a ticking bomb, and you have to make sure that he's not doing anything stupid to your application. So sanitize user input. And how can we abuse this decoded cookie? As you guys saw, we changed the input and we re-encoded it back, and the application blindly trusted our input. So what have we learned so far? The mindset: read, identify, analyze, and plan. User-controlled input is the biggest suspect for being vulnerable in any web application, not just CTFs, any web application. Okay? And we learned how to identify base64 visually. So you guys noticed how base64 looks like, right? And, oh, okay, I skipped a bit too soon. And that's pretty much all we learned, right? Okay, so someone is saying repeat the previous slide. I'm just going to do this really quickly. User-controlled values. If there is a website or an application that takes input from the user, and you can decide what this input is, you're manually typing like first name, last name, description, whatever, username, right? You are inputting something. That's what we call a user-controlled value. Most likely, you can abuse this value because the application will handle your value in an incorrect manner, such as we saw with the cookie. When we changed the cookie, right? When we changed the cookie, and the website blindly accepted our cookie, and just edited, made us think that we're admin, right? All right, so let's get started. All right, just focus with me, guys. We got some really interesting content going on here. Okay, so second challenge called HiQ Lover. While we are talking, let's take advantage of so many things going on here. Let's go to challenges. Let's go to HiQ Lover. Where's HiQ Lover? Here, elite difficulty, of course. All right, so we're going to launch this while we go back to the slides. So what did we just learn? Remember the what are the 4 steps that we learned? Can you guys remember what they were? Read, identify, analyze, and plan. Yes, good job. So let's read. Can you find a way to read /proc/self/environ from the system? Okay, this is a file. So this is a file on a Linux system. So that's what the description is saying. Does that mean that I have to SQL inject the challenge to become admin? Does that mean that the admin wants me to somehow find some zero-day exploit in the Flask framework and get a shell on the computer? Does that mean that the challenge wants me to brute force a login page like many eager CTF participants do in CTF? Just launch brute force tool on pray to God? No, the challenge, the description is as simple as it gets. That's why the most important thing is you read the description. Sometimes I promise you, people will launch the instance and they're not going to look at the description, and they start running their buster and they start smashing the challenge. They start nmapping the URL for some reason, and then they call me over to the desk and they're like, Yousef, I've been spending 3 hours on this challenge. Why haven't I solved it? Then I will pretend not to laugh and I will just take them to the description. So save yourself this embarrassment, read the description. So we have the website. Let's open it. Let's do the identify and analyze. So very quickly, we have a website here that says HiQ level, HiQ lover. Here are some examples of HiQs to browse. There's a funny one. I'm not going to bother reading. Going outside and kittens. Cool. Awesome. So analyze. What are we doing? Let's identify, the goal of the challenge. Identify the goal of the challenge is to somehow read a file on the system called /proc/self/environ. Let's analyze what we have. So what technology does this website seem to be using? Let's right click. Let's go view source. Again, do you guys see anything going on here? There's really nothing going on. I just see these very interesting links here. Haiku, funny.txt, outside.txt, kittens.txt, right? So do I have user-defined input or user-controlled input? Where is the user-controlled input here? I'll show you. See at the top of the URL here, you guys see this? See this? What is this? At the end here, I have a HiQ equal kittens.txt, right? If I change this, I'm gonna just suffer a little bit while changing this. A funny one here, I changed it. It became funny.txt. Wow. So this URL parameter, I'm just gonna, I did not mean to do that. I'm just gonna, what happened? I gotta zoom out for this. What happened? Error, no such file or directory. /app/haikus, blah, 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 blah. So, cool. So we caused an error. And the error in the application showed us what the full path of the application is. So we're learning a lot of information. And we know that this is user-controlled input. Let's go back to our slides. So we know that the goal is to abuse the system to read /proc/self/environ. We know that we have one user-controlled URL parameter, which changes the website. And we need to abuse this URL parameter to read files. Some of you, mashallah, you're intelligent and you already know what this is. And I'm just taking it step by step. All right. So this is the challenge source code. Let's take a look at it. I know some of you might be already having heart attacks looking at source code. Don't worry. I'm here. I'm going to walk you through. This is Python. So we have a variable called HiQ. We set it to the argument in the URL called HiQ. No problem. We try to open this function in Python tries to read files, right? So we try to open, this is get working directory, so the current folder we're in, /haiku, and it reads. It reads the content from that file, and it spits it back out. If there's an error, it gives us the error. Great. So now this might look like normal code. Yeah, Yousef, I mean, this is how I'm going to store my HiQs, right? There's nothing wrong with this code, except there is something wrong with this code. Introducing local file inclusion, your new best friend. So what is local file inclusion? It is one of the WASP top 10 web vulnerabilities. It is one of the most prominent web vulnerabilities out there. What does it mean? So LFI, as we professionals like to call it, is a type of web vulnerability where a user-controlled input allows you to read any file you want on a system, any file you want on a given system. Using this exploit, we can read /proc/self/environ. Now you're going to ask me, okay, Yousef, Mr. Big Brain, how did I look at this piece of code and how did you know that this is vulnerable to LFI? I mean, number one, I wrote the challenge. But apart from that, how can I know that this is vulnerable to LFI? Well, because this variable haiku over here is placed directly in the code. There is no filter, right? There is no filtering going on. Remember when I said sanitizing, you have to sanitize user input? Where's the sanitization? I just took the value from the URL and I put it in this open function call. So I can put whatever I want. I can literally put whatever, any value I want. They're not filtering anything. And so always, when you don't use the proper ways of handling user input, okay, you're always going to run into these kinds of problems. So how can we explore, how does this work? How does this work? How can I, what type of magic input can I put that's going to read the file for me? Well, introducing your new favorite character, which you're going to learn in a second. So in order to read /proc/self/environ, it's a bit of a mouthful, we need to somehow reset the file path to slash. Because remember, we're reading from /app/haikus. We need to go back to slash and then put our path. How can we do that? This is because the application, it's in /app/haikus. So to achieve this, we're going to have to use our favorite string in Linux, which is //. // in Linux, what does // mean? // means going up one directory. Okay, so I want you to analyze this. Okay, take a look at this. Take a look at this example right here. I am in a directory called /home/deadpackets/temp/deep folder/really deep, and I want to read /etc/flag.txt. Okay, I can do that by /home/deadpackets/temp/deep folder/really deep, and then I need to put enough // to cancel those folders, and the Linux system will inevitably translate this to /etc/flag.txt. So this is my input. The Linux system cancels these red folders over here because of these // and it becomes /etc/flag.txt. So using this information, let's solve. So we know that we're 2 folders deep. So I'm going to come up here. Let's come up here. .. Okay, it acts a bit weird when you type .. proc self environ. Did I write it correctly? Yes. Press enter. Zoom out. And we get a bunch of stuff that's going on here. There is a lot of stuff going on here. Help, please help. Well, thankfully we have the power of Control F. We're going to look for flag. There you go. Flag equals, and we have the flag. That's our second flag of the day. So using local file inclusion, that we managed to solve the second flag. We managed to abuse the unfiltered user input that is being sent directly to an open call to read any file we want on the system. And this works for any file, by the way. I can read /etc/password, right? Here's /etc/password, right? We can read the source code of the application itself, funny enough, right? app.py. Oh, I think it's called main.py. There you go. That's the source code of the application itself, right? So that's LFI. All right. So being able to read any file we want on the system. All right, cool. Let's go back to our slides. How did I get to the source code? Oh, okay. So this is kind of some like internal knowledge that if you cause an error, you see that it's /app/haikus. So due to my experience, what makes sense is there's going to be a /app/main.py, because that's how most Flask applications are. That's just my experience as a web pen tester. You don't have to worry about that. All right, don't think too much about it. Okay. If I asked you to dump, if the goal of the challenge was for you to dump the source code, I would have put a hint in the description. Okay, I'm not even. All right, let's go back to the PowerPoint. So we're going to create a payload of, oh, by the way, you can put as many // as you want. Okay, but for me, I just put 2 // because we know how many folders we have to evade. And this will give us the flag. So what did we learn this time? Again, we learned how to cause errors in an application to gain information, as we just did when we caused an exception. We learned what folder we were in the application. And we learned the knowledge about LFI bugs and how to exploit them. And we used the read, identify, analyze, and plan steps to solve another challenge. All right? You not giving us weekly content is evil. I wish. All right, let's move on. Final challenge. So before we move on to the final challenge, right? Are you guys following along so well? Are you guys following along well? Yes, all good? All
Maybe
great?
give them time to solve the challenge.
Yeah. I'll give you guys 5 minutes. It doesn't really need that long, unless you've been following along. Go ahead and deploy the challenge and solve it on your own. I'll be here. Like, if you've already solved the question, you can use these 5 minutes just to ask me questions real quick. Follow up with any questions you have about LFI or the first challenge, the cookie challenge. All right, let's move on to the last challenge. Yeah. Okay. So welcome card. Okay. Let's deploy the challenge. Let's come here. Let's stop my instance. Welcome card. Another elite difficulty. Must be insanely difficult. So while we're here, let's look at the description. I want you guys to take a very important look at this description, because there's a story behind this description. Can you generate a very special welcome card that gives me the Flask config object? So what do you guys, when you hear this, what do you think? Like, what do we learn about the challenge? Just write anything in the chat. Just give me, brainstorm. What did we learn? Okay, some of you again are intelligent and you know what to do. Flask config. Okay, that's just literally repeating a phrase from the sentence. It's just zero processing happened over there. All right. Okay, I'll show you what has to be done. Okay, so let's talk about welcome card. So let's just open up the website real quick. Here we go. All right, so there's a website. It's welcome card. Generate your card. My first name is give me, and my last name is flag. I'm gonna write a random description. Okay, submit, and it just gives me this welcome card. Okay, amazing, fantastic. So that's pretty much it. That's the entire website. Let's view source. Is there anything going on here? There's nothing going on here. It's just, again, just one single page application. So let's go back. So welcome card. Read. So we read the description. It says we need to generate a card that contains something called the Flask config object. Now, again, from this description, we can understand that this application is written in the Flask framework, which is a Python web framework for building websites. Okay, so that's what it should give you a hint that this website was built in Flask. Now we need to identify the goal of the challenge. We need to find a way to dump the Flask config object. Okay, and analyze what technology is this website using. Well, it's just a page that lets you generate HTML pages. So there's not really much going on, and there's nothing to do. This is supposed to be plan instead of page, but nothing to do but abuse the data on the page. That's our plan. So I'm going to introduce you to probably the most important skill, even when you get a job. All right, this is actually more important when you get a job. Using Google. I'm going to teach you how to use Google, because some of you don't know how to use Google. Okay. Sometimes the bug is not obvious, such as this example, and we need to use the internet to get more information. Using automated tools like Burp Suite and SQL Map and such like that, it's going to take too much time and generate too much false positives. We don't have that time. In the CTF, time is essentially money, right? Unless it's a community CTF or like a charity CTF where there's no money. In that case, waste all the time you want. But most of the time, time is important, right? So using automated tools would waste too much time. And we can use the description to reduce the scope of our Google search. We're not just going to search Flask website hack. I'm going to get like 200 results. Okay, so Here's what I ended up Googling. Flask website vulnerability to dump the Flask config object. We can see these 4 results that I got. Okay. This first one doesn't look like it's related to what I'm trying to do. This looks like Flask documentation. This hack tricks somewhat looks like it's going to help me. And then I see here, any callable items config object can be called through SSTI vulnerability. And I can see here, right down here, we can dump the contents of the config object by using the payload. Amazing. Amazing. So looks like these results automatically helped us to find the vulnerability that we're supposed to find. So let's move on. Yes, Hacktricks is an amazing resource, okay, but this specific example, it didn't give us the result that we want. So what is server-side rendering? So we're gonna first I'm gonna explain to you a technology called server-side rendering. Server-side rendering is a technology in which HTML is rendered with variables on the server before being sent to the user. So we render the HTML page before we send it to the user on the backend, on the server side. This is how most websites generate dynamic content, such as placing your username at the top of the page when you log in, and other such examples. They render the HTML on the server side with the content that you need, and then they send it down to your browser. If user-controlled input is used incorrectly in this rendering process, you can hijack the rendering process to dump other things or execute code. How do we test for server-side template injection? So server-side template injection is what happens when you incorrectly handle user-supplied input to this rendering process. So SSTI is a vulnerability where user input is used to render HTML on the backend in an insecure way. Extremely dangerous bug because it always leads to command execution, which is command execution, if you know anything about security, is the worst kind of bug that your application can have because you literally take over the entire system. Luckily for us, it's very easy to test for. So since this is a Flask application, it's most likely using the Jinja templating framework. Again, you can find this out using Google. And let me show you how you can test for local file inclusion. Let's try putting double brace, 9 times 9, double brace. Let's do that. So we're going to come back here, double brace, 9 times 9, double brace, and submit. Look at this. It actually computed our 9 times 9. It became 81. This is what server-side template injection. This is how we tested and we verified that this application is vulnerable to server-side template injection because it executed our 9 times 9. It didn't just spit it out as code. Why this method? So because I know that the website is using Jinja, from experience, I know that Flask often comes with Jinja. And so the templating brackets in Jinja are double brace. Okay, there's amazing resources online such as payload all the things. Let's just go to payload all the things really quickly. This is a GitHub repository of like explaining every single vulnerability to ever exist. Okay, server-side template injection over here. We're gonna click on it, and if you read, there's ASP.NET, Java, Groovy, JavaScript, Python, Jinja 2. Okay, click on Python Jinja 2 and basic injection. Here you go. See, they tell you how to test. All right, so let's go back to our slides. Thank you so much. And so we tested successfully that this website is vulnerable to template injection. I need to pick up the pace because we're running out of time. So this is the code again. So we're getting post request. We're getting a variable called description. We're rendering the description directly without any filtering. And then we are rendering the rest of the template. You can see here, this is how the template looks like. You see these variables, curly brace, first name, curly brace, last name, and then there's some code being generated here and the description. So why did 9 times 9 become 81? Because it's being handled incorrectly and it's being passed directly to the template renderer, Jinja 2. And so it actually executes the 9 times 9 to become 81. Instead of 9 times 9, we can replace this with any Python code, import, OS, system, whatever you want to do, and it will get executed. This is why SSTI is extremely dangerous. So what do we know so far about the challenge? We know that the challenge is vulnerable to SSTI, but how can we dump the Flask config object? Well, I don't know. Let's Google. So learning how to Google efficiently can be critical in a CTF. Searching Flask config object CTF, that's not going to be that much better. You're going to get millions of write-ups, you're going to get millions of results, but searching use SSTI to dump Flask config object is much, much better. So as you can see here, Flask SSTI config object, you can see that these two results that we got. If you remember, we saw them previously. Let's look at this Medium article. I clicked on Medium article. You can see here that, let's look at this. The config object is a Flask template global that represents the current configuration object, blah, 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 blah. Okay, viewing these configuration items is as easy as injecting a payload of curly brace, config.items, open brace, or open brackets, curly brace, curly brace. So they gave us the payload. They told us what the payload is. So using the SSTI bug, we're going to input a payload of config.items, and that should dump the flag. So let's try that. Again, config.items, submit, and we get this bunch of information. Let's do Control F for flag, and there we go. Flag, we got the response. If you want to execute Python code, do you have to put curly brackets? Yes, you do. That's how the Ginger templating algorithm works. Oh, config worked as well, I guess. Let's try that. I mean, it's a dictionary, so config is literally a Python dictionary. So yeah, that's also going to work. It's just going to dump the whole class. Yeah. Trying my best. You guys are making it really hard to not laugh at your comments. All right. So what did we learn this time? We learned how to use Google efficiently to gain new information and research technologies. Okay. We gained knowledge about server-side rendering and SSTI, and we used the read, identify, analyze, and plan. And remember, I told you this is extremely important. Read, identify, analyze, and plan to solve the challenge. So those are the three challenges. So let's go through a summary of what we learned today together. All right. We remember again, read, identify, analyze, and plan. And I want you guys to type it in the chat. I want it to become your mantra. Just read, identify, analyze, and plan. Trust me, so many CTF, like remember this Ginger challenge? Okay. We had a similar challenge like this in Dubai Police CTF a few weeks ago. And so many people were just trying to get code execution, and they're trying to execute commands on the system, and they're telling me, why is this not working? All you had to do is just one payload, config, one word, config, and immediately you're done. Okay? So read, identify, analyze, and plan. We learned about cookies. We learned about local file inclusion and server-side template injection. Yes, say it, the order does matter. I'm not going to plan before I read the challenge. What am I planning for? Am I planning, inshallah, for me to get last place in the CTF? So we understood the importance of efficiently using Google to learn new knowledge or assist in solving. Okay? And we took the first brave steps. I'm proud of you guys for becoming an expert in web security. I mean, inshallah, I hope to see one day that everybody here becomes an expert in web security. I hope you guys learn and use this knowledge to solve many CTFs, inshallah. All right. So for that being said, at CTF.ae, we take pride in creating one of the biggest CTF communities that we have here in the UAE, filled with creative and passionate minds of all ages, of all experiences, that want to learn more knowledge, they want to absorb more knowledge. So I implore you to come join us on YouTube, follow us on Twitter, follow our socials, come on our Discord server. Our Discord server is filled with players that have played all of our CTFs, community write-ups. You can come talk to us, right? Ask us questions, engage with our community. One of the biggest CTF communities that we have here in the UAE.